So in both parts of this experiment, you will actually not have any glassware. You won't have a bin with any glassware, but instead, everything that you're going to be doing is done in these 24 well plates. This is kind of the same material as like a Petri dish in a biology lab. It's this kind of hard plastic. There's 24 wells in here, 1, 2, 3, 4, 5, 6, and then there's 4 rows of them, so we have a grand total of 24 wells. For part 1 of your experiment, you're going to use this index card as kind of your staging ground for looking at the different reactions you're going to be evaluating. You're going to be using a total of 4 different solutions. Those solutions are zinc chloride, nickel sulfate, copper chloride, and deionized water, and testing how these different metals react with those different solutions. So if you look at this plate, or at this figure here, you're going to put zinc chloride in A 1 through 3. You're going to put nickel sulfate in B 1 through 3, copper chloride in C 1 through 3, and then deionized water in D 1 through 3. Now the role of these different substances the roles of these substances vary. For instance, deionized water. The purpose for the deionized water is to basically act as a control, to see how these different metals react or don't react with water. We're not expecting these metals to react with water, so you would expect no reaction to be present there. In the other wells on this plate, and I'm going to open up to page number 72. On page 72 of your lab manual, you'll see this metal reactivity series. The metals listed at the top are most easily oxidized. Lithium is a metal that is very easily oxidized and very easily produces a lithium ion by losing a single electron. Now, thinking about the periodic table, where lithium is in the periodic table. Now I'm going to flip to the periodic table in our lab manual. Periodic table found on pages number 98 and number 99. I'm going to open to page number 98. Lithium is a group 1 metal. So lithium very easily forms a +1 ion. Now, lithium as an atom versus as an ion, that's an important distinction to have. Lithium, an elemental form of lithium or an atom of lithium, will lose 1 electron, therefore it gets oxidized. So oxidation is the process that something will lose an electron. So lithium will get oxidized, losing 1 electron, forming a +1 ion. Now, that's basically the run-up on this. The things that more easily lose electrons are at the top, the things that are less likely to lose electrons are at the bottom. Something that's unlikely to lose electrons and become oxidized and break down into an ion would be something like gold, platinum, or mercury, or silver. All of those are metals that have a higher dollar amount because they don't get easily oxidized. Okay, so what you're going to do is you're going to put the solutions into these 3 wells. Then you're going to take a small piece of one of those metals and put it into each one of those 4 different solutions. And you're going to watch to see if a reaction takes place. Now, to illustrate this, in our wells B1 through 3, we'll have a solution of nickel sulfate. That's nickel ions and sulfate ions present in that solution. Those nickel ions are floating around, those sulfate ions are floating around. Now, hypothetically, if you put a metal, and I'm looking at page number 72 here, if you put one of those unknown metals into that solution of nickel ions, that metal, and a reaction takes place, that metal could be anything from cobalt all the way up to lithium. Because a solid metal, an elemental form of a metal, will react with an ion, provided that that ion is below it on this reactivity series. So if you put solid lithium in the presence of nickel ions, that solid lithium will be oxidized and the nickel ions will gain those electrons. So when one thing gets oxidized, another thing gets reduced. And reduction is gain of electrons. So for part 1, what we're looking to do is we're looking to say, when we mix our unknown metal with that nickel sulfate solution, that solution with nickel ions, and we see a reaction take place. What can we say about it? Well, we can say that metal could be anything from lithium to cobalt. Based on that reaction alone, could you conclude what that metal is? You couldn't, which is why we're introducing other solutions, zinc chloride and copper chloride. We're trying to narrow down under what solution conditions or under what conditions does a reaction take place. If this metal is put into solution to the zinc chloride solution, no reaction takes place. But then we put it in the nickel sulfate solution and a reaction takes place. Well, that would say it could be cobalt all the way up to chromium. It could be cobalt, iron, or chromium. What I want you to do is name what the metal could potentially be, not to hammer down one specific answer. Instead, I want you to use kind of qualifying language and say, based on my observations or based on what you see, what do you have confidence in saying that it is? All right, so that's part one of your procedure.